The probably most hyped printer ever. The first commercial printer with clipper out of the box, and the Voron 2.4 as the most anticipated example for do-it-yourself. The new fast generation, tested and compared for your decision making. Let's do this! This video is sponsored by PCBWay. PCBWay offers a wide range of services like 3D printing, CNC machining, sheet metal fabrication, injection molding and of course PCB production. Getting a quote for your project is easy. Upload a file of your design, specify the parameters and you're ready to go. Check out the link below in order to go the PCBWay with your project. Psst! An upcoming 24/7 printing project will also go the PCBWay soon. Subscribe and don't miss this. Really fast printing was kind of reserved for hardcore enthusiasts building and tuning do-it-yourself printers like Havertz, Vorons, VisiBots, Redrix or others. The holy grail and enabler for those crazy speeds, Clipper firmware, along with resonance compensation aka input shaping. Check out my last video where I test the Clipper boost on low-end i3 style batslingers. Meanwhile, we have Clipper out of the box. The FSR V400 is the very first printer with Clipper pre-installed and pre-configured. That's an absolute novelty as it claims to take away all the Clipper hassles. Does it? We'll see. The X1 Carbon might be the hottest piece of hard and software I've ever seen in consumer 3D printing. A crazily hyped package which promises very high print speeds as well as print quality at maximum reliability. But you shouldn't buy it blindly. I'll tell you why. Last but not least, I built the probably most popular do-it-yourself printer in order to include it into this comparison of enthusiast printers. The famous Voron 2.4 R2, built from an LDO Motors kit also running on Clipper firmware. Does the new generation of consumer printers make do-it-yourself printers like the Voron 2.4 obsolete? I doubt it. Alright, let's check out what we have here and which one might be the best choice for you. But first, a thank you to FLSun, Bamboo Lab and Jason from LDO for providing the review machines. As always, I am 100% free to state my personal opinions and you'll see that I'm absolutely not shy to do so. The FLSun V400 is a Delta printer advertised with a build area of 300mm in diameter and a stated build height of 410mm. It ships for around $1,000 and is still on various pre-order waves. Bamboo Lab silently developed the X1 printers over the last 2 years, led by former DJI employees. The promises concerning the specs, the features, as well as the price were mind-blowing and sounded way too good to be true. The coverage and statements of numerous influencers just before the Kickstarter campaign were overwhelmingly positive. This altogether pushed the Kickstarter campaign to crazy heights. Did Bamboo Lab deliver to its promises? And what's the catch on the X1 Carbon, which sells around $1,300? After many hours of testing both a review and a Kickstarter unit, yes, it truly is a game changer, but still, there are downsides which have to be considered before buying. And there is the popular Voron 2.4. A fast and engineering grade 3D printer as a contender and example out of the do-it-yourself world. No, wait. A Voron 2.4 isn't a 3D printer. It is a blueprint or a recommended specification for a 3D printer. Voron printers are meant to be sourced, printed and built by yourself. Thankfully, there are meanwhile shortcuts for this journey. For around $1,500, LDO provides probably one of the best Voron 2.4 kits available on the market. Now, considering the price range of around 1,000 to 1,500 units we are looking at, these clearly are enthusiast machines and the expectations may set to be high, concerning the features and concerning the user experience. So, what do you get for your money? All three printers feature dual gear direct drive extruders. For the Voron 2.4 I chose the Clockwork 2 variant on the Stealth Burner toolhead, which is supported by the LDO kit including a toolhead PCB and all necessary parts. LDO sent me a Faders Rapid hot end with the kit, but be aware, consumer kits mostly don't ship with hot ends, they need to be chosen and sourced by the user. The X1 Carbon uses a proprietary injection molded extruder unit with hardened steel gears, which is compact and lightweight. The hot end nozzle combination is also proprietary, which has an impact on how you change nozzles on a Bamboo Lab printer. More on that later. The FSR V400 comes with a custom extruder design along with Bondtech style gears, and we have an extruder integrated heatsink for the hot end. The Volcano Block knockoff comes with a lot of thermal paste and kind of a special nozzle design. And of course, I checked out its performance. All three printers feature auto bed leveling out of the box using different approaches. The LDO Voron 2.4 comes with the Voron specified inductive probe and an additional kit for the clicky probe modification. For now I used the inductive probe, but I am not happy with the accuracy and the repeatability. So I'll try the clicky mod and or the Pepperl & Fuchs probe, just like used on my Red and some of my other printers. The V400 uses an attachable switch probe which works great, but you won't use it very often though, as the build surface won't move. The Bambu X1 Carbon uses load cells arranged on the print bed as well as the Bambu Micro LiDAR for a redundant approach. As long as you use glue stick and as long as you don't have bubbles on your print surface, you'll experience nice first layers almost all of the time. Other than the V400 and the X1 Carbon, the Voron 2.4 and the LDO kit are not specified for filament runout detection. There are mods around you can build though. The V400 comes with a conveniently sized and very responsive touchscreen, which also includes the computing unit for the printer operations. The so-called speeder pad can also be used for clipperizing other printers, and it will be also sold separately in order to do so. The X1 Carbon comes with a nice capacitive 720p touchscreen. The responsiveness of the human-machine interaction is a bit too laggy for my personal taste. Not a big problem at daily use, but worth mentioning. As a clipper heritage, the Voron 2.4 is specified for an old-school mini 12864 LCD display with knob wheel control. I rarely use displays on most of my printers anyways, and I still like the old-school way, so I don't really care here. Nevertheless, that might feel kind of outdated for some people paying $1,500 for a kit in times of clipper screen compatible touchscreens. The Voron 2.4 and the X1 Carbon are meant to print engineering grade materials like ABS, nylon and polycarbonate. Both feature an enclosed build space. The LDO kit provides all panels needed. The LDO Voron 2.4 kit also comes with a nice and bright LED kit and all the electronics for the stealth burner toolhead illumination. This looks cool and is also quite practical. The FSR V400 comes with built-in LED stripes on the toolhead, which helps for checking out your prints but lacks illumination of the build space. The lighting of the X1 Carbon is kind of weak and that's a pity, but it's enough for having a glimpse at the print progress and to use the built-in camera for live feed recordings and time-lapses. For the V400 and the Voron 2.4 you need to find your own camera solution. USB cameras are more or less plug and play on Clipper though. All three printers depend on resonance compensation in order to have a chance to go at the advertised print speeds at a certain print quality, but we'll see later. On the LDO Voron 2.4 kit you have to do the resonance measuring by yourself. You use the provided LDO input shaper toolkit, which works perfectly. The V400 comes pre-calibrated from factory. There is no accelerometer provided for measuring the resonances of your specific machine, which is a problem. For the X1 Carbon you just press a button in order to start a full calibration sequence including resonance compensation, and it's ready to go for fast printing. The measurements for flow rate compensation is also done automatically by the machine, using a built-in micro LiDAR unit consisting of a camera, a laser and a LiDAR. For the Voron 2.4 and the FSR V400 you have to do the clipper pressure at once tuning procedure by yourself and for each material. That's one example for the efforts involved in order to get started with printing. Let's have a look at those. Even though the FSR V400 is a big boy concerning its height, the assembly steps are quick, easy and well guided in a good manual. The same counts for the configuration steps in order to start the first prints from the pre-sliced models of the USB stick. After less than 2 laid-back hours of assembly and setup, I was able to start the first print on the FSR V400. Concerning build time and efforts, do-it-yourself printers like the LDO Voron 2.4 are something completely different. Even though you don't need to bother concerning the sourcing of the parts anymore, you still have to fully assemble, to config and to calibrate. You can easily plan 30 to 40 hours for the build plus configuration and calibration. In addition to that, don't forget about the large number of ABS parts you have to print or source beforehand. Depending on the printer used for this and the options you want to print beforehand, the print time can easily exceed 200 hours. This is over 8 days of non-stop printing stinky and unhealthy ABS. Nevertheless, getting the slicing and printing started for the LEO Voron 2.4 is quite easy, as you'll find presets, for example on the Prusa slicer. Those presets are set quite slow and they are far from the printer's limits, but it's reasonable to start with this. You also get a specific Clipper printer config file from LEO in order to do the configuration quickly. For the V400, I received a Cura profile from FLSun, which I used on Cura version 5. Fun fact here, the only feature that is actually set for the advertised 400mm per second is travel movement. It's not set to print any feature at the advertised 400mm per second. We love marketing, don't we? The X1 comes with its dedicated bamboo slicer, which is based on Prusa slicer, which is based on Slick 3R. It comes with helpful additional features and meanwhile with near to perfect slicing and material profiles for fast printing at quality. This is what I personally expect from printers at the price range we are looking at. Good hardware and good software. For the performance comparisons concerning print times and print quality, I first used the default profiles for the printers. I only varied layer height, wall count, the infill percentage and the number of top and bottom solid layers for each model. This gives us an idea about the performance you can expect out of the box. The Voron 2.4 is fast in comparison to the Prusa, but quite a bit away from the print times of the other contenders. We'll give it another try with optimized settings, as the Voron 2.4 is not really close to its limits with the default Prusa slicer profile. The stringing on the V400 Benji can be solved with optimizing the retract settings. Though the lack of details on the Davy Jones print can't be solved that easily on the V400. It suffers from quite some smoothing of the details in comparison to the other printers. Smoothing is a sign of too fast printing, and/or faulty input shape or calibration, and/or incorrect belt tension, and/or general mechanical issues. Checking the details of Davy in comparison shows the motion system of the X1 Carbon as well as the resonance compensation does an awesome job at those crazy speeds it goes. The smoothing on the V400 is obvious. Many details are weakened or not existent. At the current state, my Voron 2.4 is better, but I have to check the belt tensions and remeasure the resonances, as the X1 Carbon still shows quite a bit more details. Turning off input shaping on the V400 and slowing down appropriately brings back most of the details, even though I assume that the belt tensions should be calibrated accordingly with the common measures. With FLSun's Clipper knockoff version, remeasuring the resonances and therefore a proper input shaping setup was not possible while reviewing. What do we learn from a machine depending on resonance compensation out of the box? It needs to be calibrated individually, and manufacturers should include the tools for this. In addition to that, measuring the printer's resonances should be a standard procedure when setting up a printer like the V400 the first time. Anyways, there is still one open question looking at the print time comparison. Why the hell is the V400 faster than an X1 Carbon? The presets in Bamboo Slicer for the X1 Carbon reduce speeds for coarse layer heights and increases some feature speeds like sparse infill for finer layer heights. For the V400 I used the general settings of FLSun's default 0.2mm profile equally for all prints, because FLSun didn't provide anything else and because it works. FLSun's high speed nozzle, which comes with the V400 and which is going to be sold separately, uses kind of a similar approach like Bondtech CHT in order to increase the heat transfer into the filament. In comparison to a regular brass volcano nozzle, the high-speed nozzle is around 20% superior. I was also very curious about the brand new CHT volcano nozzle I ordered and received recently. As you can see, it puts one on it and shows great potential. But it's also more than double the price of FLSun's high-speed nozzle. Coming back to our three contenders, the feasible PLA extrusion flow rate on the X1 Carbon is between 18 to 20 cubic millimeters per second. This is sufficient and superior to an E3D V6 or Revo, but there is room for improvement in order to go faster at coarse printing. The second reason for the V400 being faster than the X1 Carbon is square corner velocity, aka jerk. FLSun implemented a little script in order to enable Cura's jerk control on their Clipper knockoff and uses high velocities for features where it doesn't matter for quality printing. With jerk control turned off in Cura, the V400 is around the same print time like the X1 Carbon, even though the accelerations of the V400 are a bit lower. That little trick on cornering velocity is the main speed advantage of the V400 and can be adapted easily for every other Clipper printer if needed. Wasn't there something we wanted to do? Oh yeah, sure, we still have to speed up the Voron 2.4 nearer to its limits. For the Voron 2.4, I did some testing and increased speed as well as accelerations reasonably. The Voron 2.4 is now accordingly fast and prints very nicely, but still noticeably slower than an X1 Carbon or a V400. The weights of the moved masses as well as the rigidity of the flying gantry and the frame don't really allow much higher accelerations or speeds for quality printing. But does that last bit of speed really matter? It's the whole package, right? And here it is really hard to not enthuse about the Bambu Lab X1 Carbon. It's a very good tool, equally for beginners, enthusiasts and even for many pro users. Receiving and using both an earlier review unit as well as the regular Kickstarter pledge of an X1 Carbon, I can say that the whole process as well as communication was and still is exemplary. Nevertheless, there are downsides you should take into consideration before buying. The solutions for nozzle changing or for handling severe clogs are either pain or pricey, as it is the easiest way to change the whole hot end assembly. Even though I printed dozens of hours on both of my units, no one knows yet about the lifetime of the parts and modules. According to Bambu Lab, most of the repairs that might occur are meant to be done directly by Bambu Lab. Mostly, you cannot simply print the broken parts or just order some of the hardware cheaply at AliExpress and fix it yourself. The injection molded parts and the custom electronics of this closed system will come from Bambu Lab. Worst case, but not really totally far from reality, after 3 to 6 years, spares and or repairs might be too expensive to keep it alive and therefore these printers could degenerate to throwaway products. This is where do-it-yourself printers like the Voron 2.4 shine. The machine is a conglomerate of quite standard components which are simply attached to common aluminum extrusions. You can print and even modify the interfacing components by yourself as the sources are mostly given. Rep concepts like this will most probably always be around. Furthermore, building, tuning, modding and tweaking is part of the do-it-yourself game and also a major part of the fun. You train your skills, you use certain tools and you might have to learn new topics. So you need to enjoy to build these assemblies and they take quite some time. Also, there won't be any official warranty or support by some Voron company for your printer. If you never liked building stuff for yourself, or if you don't want to take the time for sandbox designs like Vorons, Redrigs and other do-it-yourself machines, go and get something else less complex and mainly pre-built. For example, the FLSun V400. The features and capabilities are not as rich as on the X1 Carbon, but you get a bit more build space and the hardware as well as the feature package are really good for the money. It is also quite convenient start into the Clipper universe without much of the hassles around this firmware. Nevertheless, there is quite some need for optimization of settings, software and add-ons out of the box from factory. A customer of an out-of-the-box Clipper printer needs to be provided with both hard and software in order to do the resonance compensation. At the current state, FLSun does not use the full potential of the V400 in my opinion, concerning speed and concerning print quality. Anyways, in general, Clipper out of the box works well with the FLSun V400. Even for first-time users who have enough vertical space for that big boy of a Delta printer. Oh, talking about space? The build space is not as advertised. A cylinder of 310mm in diameter and 410mm in height. It's cone-shaped and that's logical keeping the kinematics in mind. Though there are no warnings for that, neither on the official slicer profile nor is there some firmware check to this. With the V400 being my first Delta printer and assuming the stated possible build volume was real, I learned it the hard way. So please FLSun, do something about that. Most people will buy because of the advertised build space. And because of the 400mm per second, which is travel movement only. Now looking at the price structure, it becomes clear. These printers are not cheap. Even though each of them is worth the money in my opinion. And please don't get me wrong now. But in the end, an LDO kit is a sourcing service. Excellently and professionally organized, with great support and with high quality parts for an open source do-it-yourself printer concept, which is appealing to quite a niche of customers. This explains the high price, as it is not a proprietary mass production machine like the X1 Carbon. So what would I do if I wouldn't own any 3D printer and if I had to choose one of those? Easy, I'd get a Bambu Lab X1 or X1 Carbon, then I'd print the ABS parts for a Voron 2.4 in around 80 hours instead of 200, and I would have a ton of joy building an LDO Voron 2.4 or other do-it-yourself printers. Oh wait, That's exactly what I did. The Bambu X1 is a great workhorse in the background. Very fast and very convenient. A do-it-yourself printer like a Voron is a playground, a sandbox, a project, and also has an emotional component. Because you made it. In the end, it's like always. You have to evaluate your own personal preferences concerning the choices you make. I hope I was able to help you a tiny bit. Please tell me in the comments, which printer would you prefer? Thanks for watching and see you soon on 24/7 Printing. Maisdreschen, geil. Both a pre-Kickstarter. It's also proprietary.